it doesn't go out to the nether regions. But in a parabola, if this is your little light bulb, then yes, the beam of light is emitted, hits the reflective surface, and shoots out to forever. And so it does make a difference in the circle doesn't have that reflective property. The parabola does have that reflective property. It has a two-way property. That is, sunlight can come in, hit this parabolic, solar cooker, and fry your hamburger that's sitting right there at the focus. Again, that's how solar cookers work. Your sound waves can come in, hit your parabolic receiver, called your satellite dish, and come back and be collected right here at the receiver that's hooked up electronically to the television in your house. The telescope lens, we're going to come back to this one. The telescope lens, which curvature produces the clear image, might be the parabola. Right? So we're going to look at, you noticed what happened when the center of the circle was used, or the focus of a parabola. They were pretty far apart. And we're going to look at a few video clips in just a minute that highlights, so what happens? What happens when we get the focus correctly calculated, and what happens if we forget to calculate the focus, or think, as we were thinking at the beginning, maybe it's not that important. Right? So the first video clip we're going to look at is what happens when we get the focus correct.
If Las Vegas was dangerous enough, the new Vdara Hotel at City Center on the Strip has a small design flaw. Or is it a flaw? It seems the south-facing tower is also kind of a giant solar collector, which then directs the sun rays into what's being called the Vdara death ray. If you're at the hotel swimming pool at the wrong time of day and season, it can actually singe your hair and melt a plastic drinking cup. Not to mention what it does to your tan. So why do I think a death ray in Vegas is even worth mentioning? Well, it's simple. Nerd.
Well, the Vdara Hotel, what shape was it?
Parabola.
Yeah, it was a parabola, and it was having the effect of being a solar collector. We've got another video clip from someone who was a guest at the hotel. Once.
Alright, so if I told you I'm sitting out by the pool, and it was so hot, all of a sudden, I could smell my hair burning, you'd think I was setting up for the punchline. No, this was no joke. This was an attack by the death ray.
When it first started happening, and then I laid down, I actually thought that, oh my God, we've destroyed the ozone layer, because I am being burned. And it wasn't until I ran under the umbrella and saw that there was no shade, that's when it dawned on me. But I could not understand why I was getting burned.
William Pinchas survived both his trip to Las Vegas and the death ray. He was laying out by the pool at the Vdara Hotel in Las Vegas.
I was sitting in my chair for maybe 30 seconds, and at that point my head was steaming hot. In fact, my hair felt like it was burning, and I could actually smell my hair burning. And I'm rubbing my head. I felt like I had a chemical burn or something was wrong. I couldn't understand it, so I just laid down on my chair, and at that point, the back of my legs and my back started burning.
Now, the Vdara is an impressive structure covered with glass. Because of the curved shape of the hotel, sunlight is intensified and reflects directly at the pool. Thus, the death ray.
It was all bright, and that was when I looked up and I saw all the light, the reflection of the sunlight coming off of the Vdara and the Aria Hotel.
Temperatures in Las Vegas are often over 100 degrees, but it's estimated the temperature around the pool was 210 degrees because of the sun reflecting off the building.
And my plastic bag that I had, it actually said...
So they're showing the plastic bag melting. There are more video clips online. One of the things I would like for you to do this for homework is to find out, how is this resolved? This is a multi-million-dollar hotel. It's not like they want to fry all of their guests. So they had to do something about it. I want you to follow up and find out, bring in any articles or information you can, about what was done to correct the hotel situation. What was done to fix it? Yes, sir. Oh, I thought your hand was up. All right, another thing I want to pass around for show and tell are a few flashlights. The flashlights operate on the same property as the car headlights. Again, look at the reflective surface, the size of the light, and just pull it together. And if we have time today, we'll go through the calculations of where does the focus need to be for the curvature that we measure on the flashlight. But what I'd like to go to next, a couple of things. There is another example that I think is pretty interesting. Archimedes was said to have used a parabolic reflector on the shore to set enemy ships on fire, just like holding a great big magnifying glass. So we've got pictures here, and again, when you go and look online for some applications of parabolas, there are a lot of cool things out there you can look for. There's one site by Mythbusters where they tried to reenact setting ships on fire from a big parabolic reflector. That could be pretty fun for you to look at. Any questions so far? Yes. All right. All right, now folks, we're going to go through just a couple more video clips. One is finally addressing this question. When we have a telescope lens, whatever diameter to whatever concavity, the equation which models its curvature to produce clear images. You are not the only ones to have said, well, sphere, paraboloid, doesn't matter, they look the same. We've looked at our graphs, they look the same. We've looked at our table of values, they're so close. What does it matter? And yet we've looked at our focus and our center, and they really are different. They're really different. So maybe it matters far enough off out in space. So we have another clip about the Hubble Space Telescope.
Hubble symbolizes man's quest for the bridge between cosmology and philosophy. And so when you go off to catch that thing and it appears on the horizon, it's a powerful moment.
The conclusion we've come to from that is that there's a significant spherical aberration that appears to be present in the optics.
It's critical to look at how you failed. And it is inexcusable the way they failed.
10 years before, by a simple mistake with a measuring instrument, the mirror had been ground to the wrong prescription. If anyone at NASA had checked it, they would have discovered that if light striking the outside edge of the mirror is focused here, light from the inside edge would be focused in a completely different place. So when they took a picture of a star, this was what it looked like.
Right.
The best arrangement they could find was to
fold it. It looked really grainy and fuzzy and not worth the billions of dollars that were spent on this venture. They're trying to take pictures and find out if there are other galaxies out there. Let's look at the rings of Saturn. Let's look at all the moons of Jupiter. And we're looking at something all fuzzy and grainy, and that's not what they paid for. So they were very disappointed in the pictures and immediately said, oh, spherical aberration. Well, what does that mean? Spherical mistake, right? They didn't really have the correct lens in there, and you saw grainy pictures. So they sent robots out into space. They sent ships out and had to use some robotic arms and replace parts of the telescope lens. So let's see now, once they fixed it, what was possible. This was their original dream.
Since 1990, the Hubble Space Telescope has circled the Earth, looking out to the farthest reaches of the universe. As one of the crown jewels of NASA's orbiting great observatories, Hubble has brought back spectacular vistas which have inspired an entire generation. Images that resemble framed pieces of art. Images so powerful that they are known worldwide. We'll take a guided tour of some of the best Hubble images taken throughout the years. Planets are captured with details revealing their complex weather systems, violent sandstorms, the dazzling light of auroras, and the rhythmic dances of moons and their shadows. Hubble gave us a ringside seat to viewing a 1 in a million comet collision with giant Jupiter. Turning the Hubble's gaze beyond our solar system, we see the birth and evolution of new stars, then their opulent death. A myriad of galaxies spiral.
All right, thank you. I wanted to just get you started here. You can watch so many beautiful images from the Hubble now that are a far cry from the first one you saw that was all grainy, not clear, out of focus. The whole point, it was out of focus. It was centered somewhere else to take the pictures, and you bring it back into where it should be on a parabolic surface, then you had very clear images, right? So what happens when you get the focus correct? We've got clear images, or we have the death ray at the Vdara Hotel. And what happens when you get it wrong? We get the out of focus pictures, right? And what I'd like to do now is introduce one more application that is a lot of fun, and that is playing FBI spy guy.
I've won this big.
You want to do this? No? I'd like to send out two people in pairs. What you do is put on the headphones, and you've got what shape? You got it. You got the parabola, and it's hooked up to this wire that has another little receiver right here that's clamped in. And on the handle is this button. You press in. It's got batteries inside the handle, so it amplifies the sound. And so you can actually eavesdrop. And so I would say, who would like to go for a walk up and down the hall? Joe and Bill? Go. Take about a 2-minute walk, come back and tell us what your experience was like, and I'll let another pair go. All right? And over the next couple of days, you'll all get to go. Yeah, don't forget to come back. All right, are there questions so far? Yeah, don't forget to come back. You know, nobody's going to suspect them of anything going around going like this. It's like, what are these creepy guys doing? But do you have any questions so far? These are cool applications, aren't they? All right. Well, one of the things that we can do right now is to take apart one of our flashlights and find out where the focus ought to be. And it's really cool. This one's already dismantled. And let me get a couple of volunteers who can measure the depth and the width. And we'll see if you can measure the, let me get you a centimeter side. Here we go. This might be a little easier. All right? So let's measure our flashlight and see if it's built the right way. That would be nice. What are some of the other reflective surfaces you could use if you wanted to build your own solar cooker, for example?
Tinfoil.
Tinfoil's good, as long as you don't wrinkle it up, right?
Yeah.
What else?
Black plastic.
Black plastic? I don't know. Guys, what was it like?
It's really